So we're in one of our spec houses in Echo Park, and so this house we built to our typical standard. We've got 2x6 exterior walls. You can see some of the caulking that is in between the studs, and you'll see it in the corners as well. So everything that we're doing is trying to air seal this house. We have our LSL headers so that we can put 2x4 worth of insulation in a 2x6 exterior wall above the windows, as opposed to being loaded with lumber like a lot of framers will do. We also have the insulation damming up here at the top, so that will hold our insulation at the correct elevation, so the correct thickness all the way to the outside edge of the wall. These are the things that help your home be more comfortable. So when we talk about how does this room feel when it's all done and you're sitting here at your desk, or your guest is using the guest room, how do they feel when they're close to the window? Does it feel chilly or not? Well, we seal, you can see the foam all around here. We caulk our window flanges. We tape our window flanges. We use Tyvek. You can see a couple of leftover rolls here. We use Tyvek, the complete Tyvek system. All of that in an attempt to be as comfortable a living space as possible for the homeowner. Okay, so you might look at this if you don't know what you're looking at, and you see this gap and go, what's that? That looks like an error, right? So we caulk this. What are you gonna do with this, right? This is filled with insulation. We do this California corner on purpose. I've got my finger, I can't fill the end of that. Well, if this stud had been right here, the best you're gonna get is the insulator would drill the holes and fill that full of insulation, and you'd never know whether it's really completely in there altogether or not. The other side of the room, I'll see if I can scoot around here. The other side of the room, we have a different thing. For a T-wall, we do these ladder braces. So that, again, the same thing is that we can get insulation all the way up in through here behind the drywall, and that way we don't have a lot of extra lumber that's keeping us from having the best insulation possible. Okay, so we're in the living room of this house. We have a vaulted ceiling. Over here on this side, there is a detail that is different from the other side of the room. So we have all of this drywall, OSB, foam around the perimeter of all these things between the frame and the drywall. The reason for that, there is a living space up above that side of the wall. There's also obviously the first floor. This is the master suite over here on this side. So the reason all of that foam and drywall insulation drywall is there is to keep the insulation that goes up on this slope from migrating down into this space where there will not be any insulation when we do a loose fill insulation on the slope. Then we don't want any air to transfer in between that space up there in the fresh air attic and the space between the living space of the first and second floor. Otherwise, you're going to end up, ultimately, over time, insulation would slide and you would end up with missing insulation at the peak of this vaulted ceiling because it would all slide downhill. On this side, however, we've got a little different scenario. You don't see any kind of blocking. We've got living space down here. We do not have living space up there. We will do an R38 insulation up there on the ceiling, on the flat, and on the slope. The insulation that is put on the slope here will be held from sliding down by the insulation that is in here on the flat. Not to mention we have an LVL. So really we're only talking about this space right here on this side because we're holding LVL all the way across here, but this here would be the only place where insulation might slide down into that space. That's the difference between the two different methods all in the same room. But all of this leads to a more comfortable home for the occupant. Whoever owns this house and lives in it is going to be much more comfortable in these spaces. All right, so a couple of things I want to point out here, and this is all about making sure that the owner of this home is comfortable once we're done with construction and they move in. So this is not needed here. We have a freestanding tub. We do this when we have a pre-molded tub or shower unit that's going up against an outside wall, but I have my framer so concerned about not doing it and making a mistake and not doing it that they put it in places that sometimes they don't need it. Drywall is going to go over this, so don't get all bothered by the fact that this is here and there's a freestanding tub here. It's not hurting anything for it to be there. So on top of that, what we have here is a niche. So, and it's an in the wall niche, so it's recessed into this space. Where's my insulation? Well, our third-party energy rater, Energy Star certified, tells me that 1.5 inches of foam insulation is better than this window for our value, the comparable U value versus our value. So we will do that right here before we put drywall into this space and then build this niche out to where it's a finished product. And again, better insulation here in the end than what this window provides. Okay, so we're upstairs and we're looking at this window. You can see that the U value, that's effectively the insulation value of the window, is a 0.3. And then the solar heat gain coefficient is a 0.22. So both of those numbers fall in the Energy Star requirement for windows if it's going to get the label. So that is what we use. They are better than a standard builder grade window, but still cost effective. We offer upgrades to higher quality windows than this if you like it, but again, this is in an attempt to make the home more comfortable for the final user, because this is what keeps the hot sun in the summertime from coming in and just feeling like you're getting, baked on the inside, and in the wintertime feeling like it's drafty. When it's really not drafty, it's just allowing that temperature transfer through the glass. Okay, so we're up here in the attic. This is gonna be a fresh air attic. We're not doing a foam roof deck on this. But you can see some of the technology that's in here. So we've got a fresh air damper. We have a fresh air pre-filter. That air comes in to the intake side of the furnace and is filtered again. So all of that to eliminate dust and that sort of thing. We also have a bypass damper, so that when only one area of the house is calling for heat and air. This is a 3-zone system. I should have started with that, but this is a 3-zone. So if one zone's calling for heat or air, this will open so that there's not too much air pressure or you're over pressurizing the system. And that allows the heat and air to run without failure. If that makes sense. So then we have all of the damper controllers that are up in here. They're a little difficult to see, but there's one of them right here. It's kind of a clear looking box. Kind of reminds me of back in the 80s, the Swatch watch, which you could kind of see through translucent case. But you can see all the electronics through that. So we've got 3 of those on the supply side of the heat and air system. Then you can see all of this foil. So this is all R8 foam or fiberglass insulation inside of this foil. So we get radiant protection plus thermal protection on all of the ducting throughout the house. And then you can see how they've strapped everything up. All of this is to make the system run efficient and very comfortable for the homeowners, the future homeowners on this particular house. So one other thing to discuss in here is the way all of this giant spider web, spaghetti noodle looking foil ducting thing looks like, right? So our heat and air contractor, according to Energy Star, does all of this based on a computer program that they enter all the information on the house. the type of windows, the Energy Star value on the windows, how many exterior doors we have, the thickness of the outside walls, the amount of insulation that we're going to put in the attic space, whether or not we put foundation insulation around the perimeter of the home, and many other details is put into this program. And what you end up with is what has been done here. The location of where the vents come into the room, so the supply vents, the location of the return air vent, where the thermostats are in the home. It used to be back in the day, your heat and air contractor would kind of wing whatever it is that they're doing. It was kind of a, well, I think this is the best, or the idea that you wash all the exterior windows with air so that all the ducts are, if you're in an older home, all your ducts are always right over the top of the exterior windows and rooms. And then typically they oversize, because you can always throw more heat and air at a house in order to overcome its inefficiency on the Energy Star side of things. We do a performance model so that we're ultimately trying to make sure that we're using as small of one of these units in order to make the home really comfortable for the homeowner and keep the utility bills down. Utility bills are getting higher and higher, so gas prices in the wintertime, if you have natural gas or propane, or electric in the wintertime and electric all summer long, those prices always go up. Energy companies, they're never lowering them. So part of this is to make the homeowner a better value long-term, and the home is more comfortable, and it's scientifically proven, and we use software to make it happen. All right, so we're up on the second floor. We can see from this point of view that we have attic damming on the second floor above the ceiling of the living space all the way around here, which is going to keep that second floor insulation from water falling off into the attic of the first floor space. And then you end up with less than R38 at the perimeter of these interior walls. That's why that OSB is up there all the way around this space. And then up above there, you can see the fresh air ventilation. So that's the top side ventilation. So warm air rises. Contrary to popular belief, heat does not rise. Warm air rises. That warm air rise will go out those vents. They come in through the continuous vent all the way around the outside of our house. We use Hardy, which is continuously vented with perforated holes all the way around the perimeter. None of those metal vents that are either louvered and have a screen that squirrels dig through, and then you've got a squirrel inside your attic. That happens. It's happened to me. And then we have another thing over here above the door to this bonus room is this metal mud ring. So our heat and air contractor actually manufactures those in-house. And so that's a transfer grill. So if you've ever stayed at somebody's house, maybe your childhood home, when you shut the door in the evening, go to bed, the next morning or in the middle of the night, you wake up and it's all stuffy and warm. This keeps that from happening. That's an Energy Star requirement that they wanted to implement, and so we do that. And so you'll see a little grill at the finished home. It'll have a grill on both sides, and that again it alleviates the incoming air pressure, allows it to get outside the room, so you don't have to have the door open all the time.